Hi everyone, my name is Dana Ovenoff, and it's my pleasure to virtually welcome you to the Maurice J. Zucrow Labs here at Purdue University. As the largest academic propulsion lab in the world, we here get to do research in combustion, propulsion, explosives, hypersonics, laser diagnostics, and so much more. But rather than tell you all about it, I'll pass it off to some of my colleagues to show you around. And if you have any questions, I'll be online at the end to go ahead and answer them. So sit back and enjoy the tour.
Hi, welcome to ZL1, where there's a lot of research that goes on in terms of laser diagnostics as well as combustion research. Let's go take a look. As a member of the Meyer Research Group, I work in laser diagnostics and especially combusting flows. Now what that entails is working on setups such as this, where this is a CAR setup, which stands for Coherent Anti-Stokes Raman Scattering, which allows you to use pulse burst lasers like this big guy right here, which send laser pulses in and can allow for us to measure temperatures in flames without actually disturbing them, because it is a non-intrusive diagnostic. So that's actually very helpful for combustion research, and a lot of that work goes on here in ZL1, in this room, and in another room that we'll just show you now. So this is the inside of a pulse burst laser that we use here at Zucrow Labs. Now, what you do with a pulse burst laser is you take your initial inlet laser and you bounce it through all of these optics and you amplify it using, in this case, neodymium glass rods. And then by dumping a lot of energy into it, you can actually amplify your laser signal, and that allows you to get large amounts of energy compared to what a laser pointer will do, and that's very useful for the techniques that we develop here. So this is another room in ZL1 where we do explosives research with using laser diagnostics. We do the explosions here in this blast chamber, which allows us to do small explosive events. A lot of research we've done lately has been involved with detonators. And then what we've been doing with them is using devices such as this. This is a quad scope. Now the quad scope allows us to image something about here and split the view into 4 different views on the camera chip with this. And using those 4 different views, we can actually 3D reconstruct what we're seeing. So we can end up making evaluations of particle sizes using only a single camera, but 3D reconstructing it, which is actually a very fascinating subject called tone reconstruction.
Hi, I'm Jay Evans. I'm a second-year grad student in aeroastroengineering, and I work at Maurice J. Zucrow Labs, or more specifically, the high-pressure laboratory, which includes ZL3 and ZL8. Just to orient you, ZL3 is where you met Scott Meyer and saw the rocket cell. It houses a lot of the original rocket cell and gas turbine test cell work that went on at Zucrow Labs, and then a couple years ago, construction finished in ZL8, where we have 5 new test cells and an all-new laser lab that spans the width of the building, where students can conduct even more high-pressure experiments and run diagnostics on them. Same kind of work, gas turbine and rocket-related stuff, or even more fundamental combustion, but more test cells and more modern facility space to do it in. All right, now we're walking into ZL3. So in addition to housing the gas turbine and rocket cell, this is also where a lot of the graduate student office space is. So you walk in. It's a pretty nice facility. You have a nice big conference room where you can have the big important meetings. I'll let Ethan kind of pan the camera around in there. And then on the other side we have professor offices, including Scott, who you met earlier. As we come further along, have a break room where students can eat lunch or interact, get coffee, things like that. Then coming further along, we have our cubicle farm space where students can do various things like CAD or data analysis. Anything that would require a computer, there's the workspace to do it in. So moving further along, there are collaboration rooms where various students are officed. Still more cubicle space. And then we start to get to the control room. So here's an example of one. We have a nice 4-monitor setup at each station with large TV screens to monitor the experiments as they're going on. Here's a bigger version with the rocket cell. And coming further along, this is where we start to get to where the test cells are housed. So you kind of have this intermediate hallway area where we're about to go to, where it splits off. We call the build-up area because students can do a lot of build-up tasks or maintenance on their experiments here. Coming along this way, here's what we call the locks room, but it's got more than locks in it, just the various propellants that mainly the rocket cell uses, but also some plumbing for nitrogen system control. Some more build-up space, and also the computers that collect a lot of the data from the rocket cell. And here's the rocket cell that Scott showed you, just to put it in context of where it is in the building. And then on the other side of this wing will be the gas turbine cell and the older laser lab. Hey Ben, are we good to go to the GT cell? Or? Yeah, you're good. Cool. And here's the control room for the GT cell. And right now there's a lot of build-up work going on in it, but here's the gas turbine cell, which is on the opposite wall of the rocket cell. And that is pretty much ZL3 and one major component of the high pressure lab.
Alright. Hey there, I'm Charlie Black. I'm Eric Johnson. And we're both graduate students, master's students here at Purdue. I'm from South Carolina. I went to Clemson University for my undergrad.
I'm from Wisconsin. I went to Milwaukee School of Engineering for undergrad.
And we're both currently aerospace students here. And we're working under Scott Meyer here at Zucrow Labs, and we're doing testing on this RCS thruster here. So basically, we built up this whole stand with all the plumbing and tankage and everything you see behind it, and all the force measurement systems and all the instrumentation. And this is everything we learned to do here at Zucrow. And when we came here, we didn't have too much experience with this stuff, but we learned how to do it, and now we are in charge of this test campaign, firing this engine. So.
Okay, now coming from ZL3, this is ZL2, and we'll go ahead and walk in here and I'll explain what goes on in this building. So to this side of me are a couple test cells that largely they're doing hydrogen peroxide based work under the supervision of Scott Meyer. So a couple test cells here, and then further down the hall. At the very end of the hall is storage area, and past that are the compressors that power the giant air system we showed you by ZL8 earlier. What's really cool about this building is right down here we have an in-house machine shop with 2 machinists. And so students have the opportunity to get a lot of their components and parts machined in-house and to interact with machinists directly, which is not only hugely convenient for moving forward on your projects, but also to get that experience as an engineer of making a drawing, talking about it with the machinist right there, and working through those problems, and at the end of the day getting the part you need. So I would say that's one of the key elements of Zucrow that makes it unique and a good experience for engineering grad students.